Hello Year 12s. I'm going to do a video going through example number 22 on page 297. So this is your modelling question with your box, so you might want to open up to that page now. And then if you read through the question, you'll see that you're given some information, which I've summarised here. So we've got the box is going to be made from 54 metres squared of sheet metal. So what I can infer from that is that this here is my surface area. And then you're told it's a cuboid and it has no top to it, no lid. So essentially, what you want to do is you want to start off by drawing your cuboid, and it's going to look something like this. I've got a little box here. So it'll have no top to it. All of these sides are going to add up to make 54 metres squared, yeah? And then you're also told that the two ends of your box are squares. So if you imagine this bit and this bit here are both going to be squares, and you're told that the height, so this distance, is x. So if you pause the video now and have a go at drawing that, and then what you should have is something like this. Like so. And then we know that the height here is x. And then because I'm told this end is a square, then I can say that this bit here is also x, because the sides will be the same length. And then that's all the information you're given. And we want to try and get the volume here. And we're going to have to use that this surface area is 54 metres squared. Now, if I wanted to make a formula for the surface area, I would need to use this x. I also need to know this. And I have no idea what this length is. It could be anything. So what we're going to need to do is make up a new variable. As you work through the questions, you'll always find that there's some piece of information that they have not given you a variable for, so then you need to make it up. In the book they call this y. I'll call it y as well, but you could use anything here. So any letter that you like to represent this length. And then now what we're going to do is, now we've got our drawing, I'm going to form two equations, one for surface area and one for volume. So the surface area I know is 54 because I'm told that in my information, and then that's going to be, so I've got two ends at either side, so that's going to be 2x squared, yeah, because this area here will be x squared, but I want this one and this one. And then you can think of the front and the back here as being x times y, and then I'm also going to have the base, yeah, like the underneath of my box here is also going to be x times y. So I'm going to need plus 3xy. And so then this is my first equation built now for my surface area. I don't want to find surface, I want to find volume. Let's have a look at what my formula looks like for volume. So for volume I'm going to do x times y. Yeah, height times length times width. So this is going to be x squared times y. Now you'll notice here that in my volume I've got this y, and obviously the thing that I want to get to up here does not have any y's in it, so I need to get rid of this y, and then this is where the surface area formula comes in. So what I need to do now is rearrange this equation to get y equals. So if I just take this over to the other side, so I've got 3xy is equal to 54 minus 2x squared, and then we can divide through by 3x to get y equals 54 minus 2x squared, all divided by 3x. Now if you wanted to, you could split this up into two different fractions here, but it's the same thing. We've got y in terms of x now, and then what I can do is I can substitute this into here where I see y, and then I'll have v all in terms of x. So this thing here needs to go into here. So I've got v equals x squared times y. Y is this. 54 over 3x minus 2x over 3. I just simplified there, cancelling down the x squared with the x, like so. And then it's just a little bit of algebra from here. And then you'll get 54 divided by 3, which should get you down to 18. If I multiply in the x squared, so I've got 18, 54 divided by 3, x squared divided by x is x, minus, and then I'm going to multiply these two things here together, so x squared times x is x cubed, so I've got 2 over 3 x cubed. And then that's part A done. Part B, given that x can vary, use differentiation to find the maximum or the minimum value of v. V is always going to be this, so what this means is that I can vary my x value, so this square could get smaller and this square could get bigger, but because I'm always using 54 metres of metal to make the box, as these x values vary, the y values have to vary. So as this square gets larger, this length will have to get smaller, and then I can plot this and I can think about, okay, what is the biggest I can make this box, which is what they want us to do now. Whenever we're asked to find maximums or minimums, you're thinking differentiate. Here we're differentiating the volume with respect to x, and so this is going to be 18 minus this times this is just going to be with 2 x squared. So this is my first derivative. In order to find the maximum and minimum, I want to know when is this equal to 0. 18 minus 2x squared is equal to 0. So we have 18 is equal to 2x squared. 9 is equal to x squared. And so then therefore x is equal to plus or minus 3. If we remember back to our question, but x value is a length because it's the length of the side of the box, so the x being minus 3 obviously makes no sense, so we can ignore that. It's up to you. You could just go straight in and just write this as x equals 3 if you notice that straight away, or if you do the plus minus, then you'll have to say that x is equal to 3, and then that's your final answer. Oh, sorry, it's not final answer. This is the value of x, where you get the maximum volume, but you're asked to find the maximum value of v. So we want to find the v for this 3. I'm not going to bother to talk you through this, but all you're going to have to do is substitute your 3 back into this equation here to find your v. If you ever look in the textbook, it's just algebra. So you're going to go 18 times 3 minus blah blah blah. Just pop your 3 in here, and then you should get your volume as being 36. Sorry, v is 36. And then for part C, you want to justify that the value found is a maximum. So I know this is either a maximum or a minimum, but I don't know which. And in order to work out which, I'm going to have to work out the second derivative. So let's start off by putting the first derivative here. So v is equal to 18x minus 2 over 3x cubed. And then now I want to find, oh sorry, I've got the first derivative, to v by dx. So I do 5b. 18 minus 2x squared. And so now I want the second derivative over dx squared. So my 18 will just disappear, and then I'm going to have minus 2 times 2 minus 4x. I know my maximum or my minimum is when x equals 3. So let's see what happens at x equals 3. And so I'm going to have minus 4 times 3 is minus 12. This is obviously less than 0. And when we have our second derivative being less than 0, then that means we're going to have a maximum. And we're done. An exam tip for you: if you get a question like this, what I would remember to do is the first part A, is the hardest. So try and think about your two variables and prove your your formula for V, but they almost always will give you that. So part A will be show that volume is equal to this, show that such and such or such and such. So if you can't do your part A, you should still be able to do the parts B and C quite easily, because parts B and C is just differentiate, set it equal to 0, solve for x, and then your C part is differentiate again and substitute your x value in. Okay, I hope that made sense. Sorry for the length of the video if I bored you. Let me know if you want another example. I'm happy to go through another question from exercise 12k if you want more help.